This is the second of a two-part presentation on the origin of cells in adipose tissue. In this presentation, I'm going to be discussing the maintenance of adipose mass from adolescence to the adult individual. In this slide, you see the two parts of these two presentations, the first part being the development of adipocytes from the embryo to adolescence. It's often been considered that the number of adipocytes that you have at the time of adolescence is the number of adipocytes you will have throughout the duration of life. So during part two of this presentation, we're going to be discussing how the body maintains a certain number of adipocytes and what are the causes of obesity. First presentation, I discussed the origin of cells in adipose tissue, starting from mesodermal-derived cells, the formation of blood islands, the formation of a vascular plexus, and then finally a microvascular network. From this microvascular network, cells give rise to all the cells found in adipose tissue and adult adipose tissue, with the exception of sympathetic innervation, nerves innervating into adipose tissue, and circulating cells. And the three different cells that all of these cells in adipose tissue have are found to be, through the literature search, perivascular cells, endothelium, and tip cells also being endothelium. And we also discussed previously that these perivascular cells are not parasites. They are often perivascular cells that are derived from the endothelial cell. So one of the conclusions, often called somewhat of a unfortunate truth, is with the exception of nerve cells and circulating cells that invade adipose tissue, all cells in fact are originally derived from endothelial cells. But what about parasites, fibroblasts, MSCs, mesenchymal stem cells, and adipose-derived stem cells, often terms used to describe the cells that give rise to adipocytes. The parasite population in fact is relatively small to non-existent. There are perivascular cells that surround endothelium, but for the most part, these are the vascular smooth muscle cells that are found around arterioles and venules. There are other perivascular cells that are found within the basement membrane of blood vessels. And these originate either from the blood, so cells that diapedese across the endothelial cell barrier, or the endothelial cells themselves. And also rarely parasites are found in association with fat blood vessels. As I discussed before, but I'll reiterate now, the fibroblast is a morphological phenotype, not a cell type. Often in tissue culture, we call these cells that have this stellate form fibroblasts. That is a phenotype. It is not indicative of a specific cell type that exists within the body. Adipose stem cells, again, are the endothelium originally. So during development to the stages of adolescence, endothelial cells give rise to adipocytes. And then finally, mesenchymal stem cells. This is a nomenclature that's flawed by a set of highly specific CD markers that have been propagated by cell societies to define a very specific cell type, mesenchymal stem cells. This term MSCs has been perpetuated by the FDA and their regulatory definitions that include chemistry, manufacturing, and controls, the CMCs, indications, potency, dosing, and quality system. It is a reductionist process where the FDA and others are trying to find a very simplistic way of defining a cell population that can give rise to other types of cells inside the body. But it has been shown that the endothelial cell can act as a perfect stem cell, giving rise to other cells such as muscle cells, such as bone cells. So again, this term MSC has been perpetuated by a hierarchical reductionist approach to adipose science. and it really overlooks the true therapeutic and regenerative cells that reside inside fat. I wanted to also point out that often you see in this figure from a paper by Roger Wagner, this figure 7 is often used to show the parasites that surround endothelial cells. And if you look at all of these images, it looks like every endothelial cell in these images, these are scanning electron micrographs, are surrounded by a huge number of these parasites. Well, this turns out to be a study where a scanning EM was taken of the blood vessels surrounding the swim bladder of the American eel. This is a paper by Roger Wagner and Fred Hostler. Using a process known as ultrasonic microdissection, they showed the existence of capillary parasites in huge numbers. Adipocytes have microvessels, but they do not have a parasite concentration anywhere near to the level of this parasite concentration found here. So I really implore everybody not to utilize Roger Wagner's figure 7 as an example of the parasites that surround adipose microvascular endothelial cells. We previously also talked about, I want to reiterate again, that there are many types of fat inside the body. There are visceral fat deposits that are found within the organs, but also intramuscular adipose tissue is considered a visceral fat. And then there is subcutaneous fat. The subcutaneous fat is often used as a site or a source of adipose tissue, utilizing the process known as liposuction. And you can see all the different sites of liposuction inside the body. I do want to say that I'm going to give a general view of continued adipose development in the adult. Each of these individual sites of fat may have a different, slightly different mechanism of formation and maintenance of fat. The incidence of obesity and medical conditions associated with obesity, examples are diabetes and cardiovascular disease, have resulted in an intense interest in how fat is formed and how fat expands and contracts throughout adult life. So much of what we know about adipose tissue today comes from our interest in trying to understand and control obesity in adolescents as well as in adults. So I'm going to spend a little time now talking about some of the background, the history of studies of obesity, and what we've learned from these studies as far as the types of cells that are found inside fat. We'll utilize that during subsequent presentations where I talk about the isolation of cells from fat, their identification, and this search for therapeutic cells and stem cells inside fat. The history of anti-obesity therapies and the history of obesity itself dates all the way back to 30,000 BC, when Stone Age statuettes, drawings on cave walls of obese humans was found. So even 30,000 plus years ago, there was evidence of obesity in humans. Hippocrates noted in around 400 BC, that there was a link between diet, exercise, and obesity. So over 2,500 years ago, it was known that in order to control obesity, intake of food and exercise were critical components. The king of Leon was reported to have had his lips sutured together because he became so obese he lost his throne. And through this lip suturing and reduction in food intake by diet, he lost nearly 30% of his body mass, could ride a horse, and got his crown back. In 1930, we began the field of drugs to be used for obesity. Dinitrophenol was one of the first drugs used to control obesity of interest. It was also a material used for the formation of TNT as well as pesticides. But it was used for a number of years and still appears in some what we'll call nutraceuticals, homeopathic medications for control of obesity. In 1933, desiccated thyroid extract entered the market as an anti-obesity drug. And then in the 1940s, amphetamines were emerged as a pharmaceutical for use in controlling obesity. In 1945, rainbow pills, and this was nearly really a bowl of different colored pills that included amphetamines that were used and provided to patients in order to control their obesity. In 1954, surgical gastric bypass was introduced, at first unsuccessfully, but then successfully, and is still used today in order to bypass parts of the bowel in order to reduce nutrient uptake by the body. And then in 1962, a major FDA change took place, the Kefauver-Harris Amendment to the FDA Cosmetic and Drug Act, that mandated evidence of efficacy of all drugs needed to be shown. This was for new drugs moving forward, but it also was necessary for previously approved drugs. You needed to show that these drugs were actually efficacious in their use. In 1963, a year later, Weight Watchers was founded. A number of drugs were taken off the market by this amendment. So the Weight Watchers Foundation was formed in 1963. And then an interesting moment took place in 1988. Studies being formed at the National Institutes of Health in Bethesda. A group of investigators studied the venom of the Gila monster, a native lizard from Arizona. And they discovered a number of compounds in the venom that included helospectins. And these helospectins subsequently gave rise to the study of a number of peptides, including the glucagon-like peptide, glucagon GLP-1, that was later discovered in use in obesity. The emergence of phentermine and fenfluramine in 1988, also this drug mixture came on the market known as fen-phen, and over approximately 10 years this fen-phen drug was prescribed to patients. And then in 1999, a $3.75 billion fund was paid to previous fen-phen users for a number of complications that were found. In 2005, GLP drugs were approved for type 2 diabetes, and it was noted that one of the effects of these drugs, besides controlling glucose concentration, was obesity. So in 2014, the first of many GLP-1 drugs were approved for obesity. And now, in this year, 2025, the sale of GLP-1 drugs for obesity alone has topped $50 billion. And simultaneous with that, Weight Watchers has filed for bankruptcy. Prior to the discoveries in the 1970s of obesity, it was believed that obesity was caused solely by the increase in size of adipocytes. And in this paper from 1978, Faust and colleagues from Rockefeller University performed a number of confirmatory studies that developed a new model of obesity, that diet-induced adipose number increases in adult rats. So diet can have an effect on the number of adipocytes inside the body, at least in rat studies. In a paper that emerged in 2008, Spalding in Arner's laboratory reported that the fat cell turnover in humans does exist. We turn over approximately 10% of our adipocytes every single year, But these adipocytes lost to apoptosis are basically reformed by mechanisms that are still being worked out today. So there is a turnover of adipocytes inside the body. But another major finding of this study was the relative adipocyte number inside the body and in different fat deposits within the body does not change during the adult period of life. So we're left with the process of trying to understand where these new sources of cells, how adipose tissue mass is controlled in the adult. As I stated before, one of the mechanisms of increased adipose tissue mass is and is still believed to be hypertrophy, where an adipocyte undergoes an expansion due to more lipid being deposited inside the adipocyte. There are also 3 ways that new adipocytes can form to replace the adipocytes that are lost due to cellular death, and that is the perivascular cells that are associated with the microcirculation endothelial cells, the endothelial cells themselves, and these 2 cells can differentiate into adipocytes. And then also, it has been discovered that mature adipocytes can undergo a transdifferentiation through a dedifferentiated cell to form new adipocytes. So that's the 3 current thought processes as far as where the stem cells in the adult, where stem cells are found to produce new adipocytes to replace the adipocytes that are lost due to adipocyte death. So how do we control adipose mass, this total mass of fat inside the body? Hypertrophy is one mechanism. This is adipocyte enlargement. Hyperplasia, which is an increase in adipocyte number through transdifferentiation of mature adipocytes and these adipocyte progenitors. Autophagy, the process of removing recycling cells, and this again is where the 10% loss of cells takes place, the loss of adipocytes takes place. And then angiogenesis, new blood vessel formation from existing vessels in the adipose tissue. Some of the controlling factors that are still under evaluation today is the peroxisome proliferator activated receptor gamma, platelet-derived growth factor receptor beta, the vascular endothelial cell growth factors, there are numerous subtypes of these, insulin itself, and glucagon-like peptide, the GLP-1 peptides. One of the more interesting papers that was published in the early 2000s by Maria Rupnik, working in Judah Folkman's laboratory. Maria studied basically the control of adipose tissue mice by the vasculature. She used a angiogenesis inhibitor being studied in Folkman's laboratory in order to treat obese mice with this anti-angiogenic factor. And you can see visually in this slide that mice treated with saline, these are naturally obese mice, did not lose any body weight, but those treated with this anti-angiogenesis inhibitor lost a significant amount of adipose tissue mass and body weight. And this goes back to one of the conclusions that Maria Rupnik made in her paper was the novelness of the formation of adipocytes from blood vessels and how control of the blood vessels may be important for controlling adipocyte mass. But I remind everybody that Elliott and Eleanor Clark, in their publication from 1940, really defined this relationship in 1940, that fat already present diminished and frequently disappeared when the circulation in nearby vessels became overactive. And they also found that this process was especially rapid and marked in mild inflammations. Their conclusion was inflammatory conditions, if you can get the blood vessels inflamed, you can reduce the amount of tissue mass. So this really is continuing to emerge, or in some ways being rediscovered, the close association of the adipose microcirculation and adipose tissue mass. And it also gives rise to even more evidence that the endothelial cell plays a critical role in the number of adipocytes found inside the body. I wanted to go back and just review this whole relationship between the control of adipose tissue mass and the Gila monster. This is what the Gila monster looks like. It is called the Heloderma suspectum, is its scientific name. I will jump ahead and show you this Heloderma actually appears in a homeopathic drug to control obesity that I believe is still on the market today under the brand name of Heloderma. It has now evolved into being just pure cane sugar globules, but at one point this Heloderma homeopathic medication contains some of these heliospectins. Well, the heliospectins gave rise to all of these GLP-1 peptides, and the FDA-approved drugs now you see here, starting with exenatide down to tirzepatide, and here are the names that we know them: Ozempic, Mounjaro. These are used both for the treatment of type 2 diabetes as well as for the treatment of obesity. So we go back and re-look at this whole process of adipose tissue mass control in adults, and what I'll now call cell cycling. As an individual in adolescence through adulthood, as they undergo an increase in tissue mass, this can be through hypertrophy of the existing cells, as well as an increase in the number of adipocytes that are found in the tissue. But adipocyte formation does not increase the mass totally in obesity. These cells are cycling through the process of adipocyte death and apoptosis, but are being reformed through these stem cells, the perivascular cells, the endothelial cells, and the transdifferentiated adipocytes that are found inside the tissue. The increase in the total adipose mass still must go through this hypertrophic process, the increase in the size of the adipocyte. When we look at the cellular composition of adipose, there is a real dearth, a real lack of data to give us an idea of what the total distribution, the relative number of cells inside fat is in situ, inside the body. 12%, and these are the two papers, paper by Ito and a paper by my laboratory. My laboratory, this publication is 1994. The Ito publication is 2009. And we see this distribution. 12% of the cells inside intact fat are adipocytes. 61% of the cells inside fat are endothelial cells. And these perivascular cells that are often considered to be the source of parasites or mesenchymal stem cells, almost all of these perivascular cells are smooth muscle cells associated with arterioles and venules. There are very few, if any, it's a very low population of parasites as part of this perivascular cell population. And then you see the formed element cells, as well as some of these macrophages and T regulatory cells do come from the endothelial cells, the hemogenic endothelial cells that are found inside fat that can undergo a form of hematopoietic differentiation into these macrophages, T regulatory cells, and monocytes. So a few facts to leave everyone with. The number of adipocytes in the body increases from birth to adolescence. During this period, adipocytes are derived from endothelial cells directly or indirectly through endothelial cell spawned stem cells. The predominant cell type in fat at all ages is endothelium. The number of adipocytes in the adult remains the same. This is essentially saying that once you reach adolescence, the number of adipocytes that are found inside your body remains the same. If you see an increase in total adipocyte mass, it is through hypertrophy of the adipocytes. 10% of adipocytes turn over every year inside the body, and the feedback mechanisms that control adipocyte turnover are relatively unknown, but certainly should be an active target to basically go after other ways of controlling obesity in humans and in animals. 75% of obese children become obese adults, and the incidence of childhood obesity is increasing. Again, we need more information on what is the cellular mechanism behind childhood obesity. Past and current obesity therapies target hunger, your feeling of being filled, satiety, gastric attention, insulin production, and metabolism. Past and current obesity therapies do not target adipocyte formation and cycling. So thank you for your attention during this presentation. You can find this presentation on my website at cvregen.com. Tell your colleagues about that. And I'm always interested in receiving feedback and updating these presentations with the newest information that is available.